Hello, I'm Walter Stone, and this second part is to discuss a binomial distribution problem. And um, there are different types of problems depending on what probability you're asking for. So let's take a look at this problem. So at one university, sophomores account for 30% of the student body. If a group of 12 students is randomly chosen by the school newspaper to comment on textbook prices, what is the probability that exactly 3 students are sophomores? Another type of problem that has the same idea is ask the question, what is the probability that less than 3 of the students are sophomores? So there's a probability of exactly 3 versus the probability of less than 3. So we're going to take a look at these little differences here. And in the third problem we have what is the probability that more than 3 of the students are sophomores? So is this a binomial situation? Well, either a student is a sophomore or they're not a sophomore. So there are 2 possibilities. The probability that the student is a sophomore is 30%. So there's our probability of success, P. P will be 0.3. That means Q must be 1 minus 0.3, or 1 minus P would be 1 minus 0.3 or 0.7. So we have probability of success of 0.3. The number of trials is 12. So we talked about n being the number of trials. So n will equal 12 in this case. X is, we're asking what is the probability that exactly 3 students are sophomores. That's 3 successes in the 12 trials. So X will equal 3 in that case. So I want, instead of using the formula that I gave you in the last video, I would like you to use your calculator. The calculator is brilliant. It's a nice thinking tool. It has the binomial table. Later, when we talk about normal distributions in Chapter 6, it has a normal table built into it. It has a student t distribution table built into it. So all these different tables we use are built into the calculator. So to get into using a binomial distribution, what the calculator has is what's called a binomial probability density function. So PDF means probability density function. And we press second key, vars, which is under the left navigation key. So if you look at the arrow keys, just under the left key where you toggle things to the left is the vars key. And we're looking at a distribution. So we do second vars. And if you do second vars 0 on the TI-83, you get the binomial PDF function. So what you will get is this window showing up. Okay, so when I go on my calculator, if I click on second, so I'll do it here. So if I click on the second key, here's the vars key. It picks up the distributions, the probability distributions. We'll be working with the normal in Chapter 6 and the t. If you arrow up or down, you go through the list of distributions. And what we're looking for is binom PDF. So there's binom PDF. And we'll also be using binom CDF. And I believe if you're using a TI-83, it's option 0 is binom PDF and option A is binom CDF. But I'm using a TI-84. If you just toggle through the window every time you do second vars toggle through the window, you'll get to the distribution that you need. So you get to this window here. What you need to be aware of when you work with the probability density function is you need to be able to put arguments in that allow you to calculate the probability. So what you need to do is with Binomial PDF, you put in the number of fixed trials, you put in the probability of success, and you put in the number of successes in those n trials. Okay, so it's always n comma p comma x. So I'll show you this in a moment. It's also good to know about the cumulative density function. So the Binomial PDF, when we go back to calculate the probability that exactly 3 sophomores were chosen, we would use PDF. But in the problems that say more than 3 or less than 3 or at least 3 or at most 3, we'll use Binomial CDF. We'll be using the cumulative density function where we add up probabilities. So it'll be good to know to be able to locate both Binomial PDF and Binomial CDF. Okay, so let's go back to the problem. So once again, we have at one university, sophomores account for 30% of the student body. If a group of 12 students is randomly chosen by the school newspaper to comment on textbook prices, what is the probability that exactly 3 students are sophomores? So here we see that X is the number of sophomores asked to comment on the textbook prices. We have X is a number of successes in the n trials. So X is going to be 3 in this case. N is the number of, N is 12, because we're looking at groups of 12 students. The probability that a student is a sophomore is 30%. So the probability of success P is 0.3. So now we want to know what is the probability that exactly 3 are sophomores. So we'd want to work with that probability. So when we have exactly 3, that means we're looking at the probability that X is 3. In that case, we use Binomial PDF. We use the probability density function. We always put in n comma p comma x. Okay, so if I'm going to calculate this, I'm going to use Binomial PDF in this case. So I'm going to click on Enter to bring up Binomial PDF. N is 12, so I do 12. Now comma is the key above the 7 key. So I do 12, comma, P is 0.3, comma, X is 3. I close parentheses and I click on Enter. And that gives me 0.2397. In a lot of cases with binomial, they usually ask to the thousandths, tenths, hundredths, thousandths. They might ask to the 10,000ths, 4 decimal places, but usually with binomial it's 3 decimal places. So that's why I rounded to 0.240. So 9 would round up to the 4 in that case, 0.240. So we use Binomial PDF n comma p comma x to calculate that probability. In the second case, we have that in a group of 12 students, probability that we want to know the probability that less than 3 are sophomores. So we want to calculate the probability that X is less than 3. Well, what does less than 3 mean? That there are either no sophomores, or 1 sophomore, or 2 sophomores. So I want to add up the probability that there are no sophomores, plus a probability that there's 1 sophomore, plus a probability that there are 2 sophomores. Now in this case, I'm accumulating the probabilities where x ranges from 0 to 2. So I use CDF in this case. So I'm going to use binom CDF n comma p comma x. And I want to add up the probabilities from x equal to 0 to 2. So notice in the CDF, the parameters I'm putting in 12.32 because those are 0 to 2 are the options that are less than 3. So I'm not putting 3 in here, I'm putting 2. So I add these probabilities that there are no sophomores or 1 sophomore or 2 sophomores. So when I do that, I'm going to click on second vars, and I'm going to go back up through my list. This time I want binom CDF, so I'm selecting binom CDF. N is 12, comma, the probability is still 0.3, comma, 2. So CDF means cumulative. It's going to add up those probabilities. So when I hit enter, I get 0.2528. To 3 decimal places, that would be 0.253. So just in case we are working with 3 decimal places. That's sometimes the customary thing with binomial. Now we want to calculate the probability that more than 3 students are sophomores. So here's a bit of a thinking that we need to do. Now we want to calculate the probability that x is greater than 3. So what are our possibilities? That means that there could be 4 sophomores, 5, 6, 7, 8, 9, 10, 11, or 12. So I want to add up those probabilities. Those probabilities correspond to the number of sophomores being more than 3. Okay? So what I also know is by the complements rule of probability that if I add up these probabilities, that's going to be the complement of the probability that x is less than or equal to 3. Okay, so if I add up the probability that x is 0 plus the probability that x is 1 plus the probability that x is 2 plus the probability that x is 3 plus the probability that x, then if I take the complement of that, I get the probability, I get this probability from x being 4 to 12. Okay, so that kind of thinking has to come into the mix here. Now, look at what I do. I can think of the probability that x is less than or equal to 3. That's binom CDF of 12, 0.3, 3, because that will add the probability that x is 0 plus a probability that x is 1 plus a probability that x is 2 plus a probability that x is 3. Okay, so I can put that in my calculator to calculate that probability. So I'm going to work with that idea. So I'm going to do 1 minus, I'm going to now call up binom CDF. So I'm going to do second vars. I'm going to select, I'm going back up through my list to select CDF. Then I'm going to do 12, comma, 0.3, comma, 3. So I'm taking the complement, I'm using the complements rule. That's 0.5074 to 5075 ish. So, but if I'm rounding to 3 decimal places, I have 7, 4, so I leave the 7 alone. 4 is not 5 or greater. Okay? So, I just wanted to be able to walk you through those types of problems. You want to look at those ideas of more than, or at least, or greater than, or at most, and be able to do some critical thinking. If you have at most or less than, you can just use binom CDF. If you have greater than or more than, you have to do the complements rule and do 1 minus binom CDF. Okay, so I hope that this is helpful. Okay, I hope all is well, and I'm really enjoying working